Have you ever felt totally powerless when your internet just stops working? Well, today we're going to change that. We're going to build your own personal network detective toolkit. And all it takes are a few simple but really powerful commands that are already on your computer right now.
Ah, yes, the question we have all asked, usually while staring at that spinning wheel of doom. The frustration is real, it's universal. But what if I told you that you don't have to just sit there and wait? You can actually become the detective and start investigating this mystery yourself.
So, how do we do it? Well, it's all about our game plan right here. See, troubleshooting isn't some kind of dark art. It's just a process of elimination. We're going to solve this whole mystery by asking our computer 4 key questions, and each one is going to give us a crucial clue.
Okay, let's start with the most basic, most important question of them all. Before we investigate anything else, we just need to know if we can even make contact with the outside world. Is the website or the server we're trying to reach even listening?
And to answer that question, we use our very first tool, ping. Think of it as the simplest form of communication you can have online. It's a quick, direct test to see if a destination, like google.com or any other server, is actually online and reachable from your computer.
I absolutely love this sonar analogy. Using ping is just like a submarine sonar. You send out this tiny little data packet, a request, which is basically you shouting hello out into the void. If the other end is alive and well, it sends a packet back, a reply, and boom, you've confirmed the connection is active. But if you get silence, well, then you know you've got a fundamental connection problem to solve first.
So what happens if your ping fails? What if you can't reach the outside world at all? A good detective doesn't just keep shouting into the void, right? No, they look inward. They start asking, wait a minute, is my own setup correct? Who am I on this network?
For this bit of sleuthing, we use a command called ipconfig. This tool doesn't look outside, it looks right at your computer's own network settings. It's designed to show you all the critical details about your own identity on your local network.
And yep, this is the perfect way to think about it. The information you get from ipconfig, that's basically your computer's digital ID card. It has everything your router or another computer needs to know to be able to talk to you. If any of the info on this ID card is wrong, you're not going to be able to connect to anything.
So to really get this digital ID, think of your local network like a little neighborhood. Your IP address is your unique house number. The subnet mask, that tells you the boundaries of your neighborhood. And the default gateway, well, that's the main gate, the router, that lets all your data travel out onto the huge internet superhighway. If any part of that address is wrong, you're effectively cut off.
Okay, but what about a different kind of mystery? What if your connection is working, but it's just painfully slow? This is a totally different problem. It's not about if you can connect, it's about why the journey is taking forever. So our next question has to be, what path is our data actually taking?
To solve this one, our tool is tracert, which, as you can probably guess, is short for traceroute. This is an incredible command that lets you map out the entire journey your data takes, step by step from your computer all the way to its final destination across the internet. You see, your data doesn't just travel in a straight line. It hops from one router to the next all across the internet. Tracert acts like a GPS with live traffic updates, showing you every single stop along the way. And by looking at the time it takes to make each hop, you can see exactly where the slowdown is. You can pinpoint the digital traffic jam, whether it's an issue with your provider or some server halfway across the world.
All right, we have one last, really crucial piece to our puzzle. We type website names like google.com, right? But computers, they don't understand names. They only speak in numbers, IP addresses. So how does that translation actually happen? And more importantly, what happens when it breaks? This brings us to our final question. What's the address?
The tool for this job is called nslookup. Its one single purpose is to act as the internet's translator. You give it a name, and it looks up the corresponding numerical IP address for you. Simple as that.
And this dictionary metaphor is absolutely perfect. The entire internet runs on this massive system called DNS, the domain name system, which is basically a giant shared address book for everything. nslookup lets you peek into that address book yourself. If nslookup can't find the right address for a website, guess what? Neither can your browser, and you'll get an error, even if your actual internet connection is working perfectly fine.
So, there you have it. 4 questions, 4 powerful tools. Let's pull this all together into a quick reference guide so you have your toolkit ready to go the next time your network starts acting up.
And here it is, your cheat sheet. To check for a basic connection, you ping it like you're bouncing a ball off a wall. To check your own settings, you use ipconfig to look at your digital ID card. If you need to find a bottleneck, you use tracert to follow the digital footprints. And to solve any translation issues, you use nslookup, the Internet's address book.
So now, you're no longer just a user of the Internet. You're an investigator. You've got the fundamental tools to diagnose, understand, and solve the most common network problems all by yourself. The only question left is, what mystery are you going to go solve first?
Hey, welcome! So today, we're going to talk about the physical side of the Internet. We're talking about two little plugs. One of them is probably in your house right now, and the other one, well, it spans entire oceans. Now, they look nothing alike, but here's the thing. Without both of them working together, the Internet as you and I know it just wouldn't work. Let's find out why.
You know that sound, right? That really satisfying click of an Ethernet cable locking into place? It's the sound of a good, solid connection. But have you ever stopped to wonder what that little plastic plug is actually doing? And what makes it so different from those super high-speed cables that form the backbone of the entire Internet?
To get to the bottom of that, we need to meet our two main players. Think of it like this. In one corner, you've got the familiar, everyday workhorse of our local networks. And in the other corner, you've got the long-distance, light-speed champion of the global Internet.
Okay, first up is the one we all know, the RJ45 connector. You've seen this thing 1,000 times. It's got that little plastic clip on top so it snaps in place, and most importantly, look closely. You'll see 8 tiny metal pins, and those pins, well, they're designed to connect to copper wires hidden inside the cable.
And here is its super high-tech cousin, the fiber optic connector. Now, there are a few different types, SC, LC, ST, but they all have one absolutely critical job: to perfectly align and protect an incredibly delicate, hair-thin strand of glass. In fact, this connection is so precise, you're not even supposed to touch the tip with your finger.
So let's recap. We've got a simple plastic plug with metal pins and a super protective plug built for a tiny glass tip. These differences on the outside are really just hinting at a massive difference on the inside, and that changes everything about how they send information.
If you can strip away the outer layers of these cables, the difference is just night and day. Inside that Ethernet cable for the RJ45, you'd find 8 copper wires, all twisted into pairs. They're built to conduct electricity. But in the fiber optic cable, you'd find a core made of glass, sometimes plastic, that's literally as thin as a human hair. And it's designed for one thing, and one thing only, to transmit light.
You know, this phrase just nails it. Copper feels the spark, fiber sees the flash. It really gets to the heart of the whole thing. One is all about electricity, and the other is all about light. And that single fact is what changes the entire game.
So here's the bottom line. The RJ45 and its copper cable send your data as electrical signals. We're talking electrons literally flowing through a metal wire. But the fiber optic connector? It sends data as pulses of light, just flashing and bouncing its way down a perfect glass tunnel, basically at the speed of light.
So, an electrical spark versus a flash of light. When you start talking about performance, this isn't some small technical difference. It's like putting a marathon runner up against a race car. So if we frame this as a race for speed and distance, who do you think wins?
Yeah, it's not even close. Fiber is the undisputed champion, no question. Our little copper-based RJ45 connection, it gets tired pretty fast. The electrical signals start to degrade and lose strength over distance. But light traveling through a glass core, it can go for miles and miles with almost no signal loss at all. That makes it absolutely perfect for incredibly fast, long-distance communication. And that brings up a really good question, right? If fiber is so much faster and can go so much farther, then why is my desk phone, my printer, my computer, why are they all still using that copper RJ45 plug? Why haven't we just replaced everything with fiber?
Well, the answer is that they aren't actually competing against each other. They're teammates, and they're designed to completely dominate in their own very different zones. One is built for the superhighway, and the other is built for the local driveway. And that difference in performance really defines where they live. The RJ45 and its copper cables are the absolute kings of the local area network, or LAN. You know, your home, your office. They're cheap, they're durable, and they're perfect for connecting devices that are pretty close together. Fiber, on the other hand, fiber is the backbone. It's what internet service providers use to build those massive networks that connect entire cities, countries, and even continents.
So you see, this isn't about one technology kicking another one out. It's about a really powerful partnership. Let's take a look at how they work together to get, say, a cat video from a server across the planet right to your computer screen.
All right, let's just break it down real quick. On Team Copper, you've got wire as the medium, electricity as the signal, the RJ45 as the connector. Its best feature is that it's low cost, and its home is the local network. And over on Team Fiber, the medium is glass, the signal is light, its killer feature is speed and distance, and its home is the global backbone of the internet.
So it's not a choice between copper and fiber. The modern internet absolutely depends on both of them, working together in this seamless, really powerful hybrid system.
I think the best way to think about it is this. Fiber is the massive, multi-lane international highway that carries data at unbelievable speeds all across the globe. But you don't live on the highway. You need that local driveway to get the traffic right to your front door. That's the RJ45. It's the final, crucial link that delivers the internet right to your desk.
So the next time you plug in that cable and you hear that familiar little click, you'll know that you're hearing the very end of an incredible journey. A journey of data traveling as flashes of light across oceans, then converting to sparks of electricity for just the last few feet, all to connect you to the world. Thanks for tuning in.
Ever wondered what really goes on behind the scenes in your school's computer lab? Well, today, we're going to pull back the curtain with a real-world case study, modernizing a school network to make it faster and way more reliable.
Come on, we've all been there, right? You're in class typing away and the computer next to you completely freezes up. But everyone else just keeps on working. How is that possible? Well, the secret is all in the network's design, and that's exactly what we're diving into.
So here's our mission. We've got to upgrade a lab with 36 computers. And the two most important goals are, number one, it has to be reliable, and number two, it needs to be easy to fix. I mean, in a busy classroom, you just can't have the whole network going down because of one little glitch.
All right, first things first, before we can come up with a solution, we got to understand the battlefield. And in our case, that's something called the LAN.
You know, your school's computer lab, it's the perfect textbook example of a LAN, which stands for Local Area Network. It connects a bunch of devices in one small area. It's owned by the school, so it's secure, and it's built to be high speed so you can share files quickly.
Okay, pens out. This is a big one for your exams. LAN stands for Local Area Network. Its job is to connect devices in a limited area, like one building or even just one room. Got it? Good. Okay, so we know what we're dealing with. Now, what's the game plan? Let's check out the recommended solution. And the solution is star topology. Just look at this. The beauty of this setup is how straightforward it is. Every single computer has its very own cable that connects directly to one central point. And this isn't some old school idea, it's the industry standard for pretty much all modern networks.
All right, so we've picked star topology, but what's it actually made of? Let's break it down and look at the key parts.
Right at the heart of our star, we've got the brains of the whole operation, the switch. When one computer wants to send some data, the switch acts like a super smart traffic cop, making sure that data goes only to the computer that needs it. For our lab of 36 computers, we'd need a pretty beefy switch to handle all that traffic.
Okay, major exam tip coming at you. The key word you have to remember for a switch is intelligent. See, older gadgets would just broadcast data to everyone, like a loud megaphone. A switch is a smart traffic cop, not a megaphone. Please remember that word.
So if the switch is the brain, then the Ethernet cables are kind of like the nerves connecting everything together. Now, we're choosing a wired connection instead of Wi-Fi for two huge reasons: speed and reliability. A physical cable just gives you that rock-solid, stable, and fast connection that won't let you down.
So we've got our parts, a switch, and a bunch of cables all arranged in a star. But why is this the best choice? Let's justify it. And here it is, the number one, absolute biggest reason to love star topology: stability. The magic term here is failure isolation. This means if one student's computer crashes or they accidentally kick their cable out, it only affects that one machine. The other 35 students, they can just keep on working. And the second big win is how easy it is to maintain. If a computer's not connecting to the network, a technician can just look at the little blinking lights on the switch to see which cable has a problem. Need to add a new computer to the lab? No problem. Just plug in a new cable. It really is that simple. Okay, let me ask you something. In a busy school lab, which of those two things do you think is more important? Is it the stability that keeps the whole class running even when one computer fails?
Or is it the easy maintenance that saves the technician a bunch of time? There's no single right answer, but it's definitely something to think about.
All right, after all that planning and decision-making, let's take a look at the final blueprint. And there it is, mission accomplished. You can see how every single computer has a dedicated wire running all the way back to that central switch. The final result? A stable, fast, and easy-to-maintain network, all thanks to star topology. This blueprint gets a big approved stamp.
All right, time for a super quick recap for your revision. Here are the 3 things you absolutely need to remember. 1. Star topology connects everything to a central point, which is usually a switch. 2. The biggest benefit is stability. If one cable fails, only one computer goes down. And 3. It's easy to maintain. Finding problems and adding new computers is a piece of cake.
And hey, if you need a really simple way to remember the biggest benefit of star topology, just picture a star in the night sky. If one of those little points of light burns out, the rest of the star keeps on shining, right? Well, that's failure isolation in a nutshell.
Okay, let's talk about a mystery that I'm willing to bet plagues pretty much every single multi-story home. The dreaded upstairs Wi-Fi dead zone. You know, you pay for that super fast internet, but there's that one room that feels like it's stuck in 1998. Well, today, we're not just going to figure out why, we're going to solve it.
I mean, does this look familiar or what? Downstairs, it's perfect. You're streaming, you're gaming, no problem at all. But the second you take a few steps up, bam, buffering city, lag, or, just nothing. It is one of the most maddening tech problems out there, but the solution? It's surprisingly simple.
All right, let's put on our detective hats and dive in. To solve any mystery, you first have to investigate the usual suspects, right? So let's start by ruling out the obvious culprits.
The very first person everyone points the finger at is, of course, the internet provider. It's an easy target. So the big question is the internet that's actually coming into your house broken?
And right here, this gives us our first major clue. See, you've got to understand the difference between bandwidth, that's the raw speed coming into your house, and Wi-Fi, which is just how that speed gets spread around. Since everything is working great downstairs, we know for a fact the bandwidth is totally fine. So, your internet provider, they're off the hook. The problem is coming from inside the house.
So, let's be super clear. Your internet service isn't the problem. Your Wi-Fi signal is, and that completely changes where we need to look for our next suspect.
And here it is, our prime suspect, signal interference. All the stuff that makes your house feel solid and safe, concrete, thick walls, metal beams, well, that stuff is basically kryptonite for your Wi-Fi. It doesn't just block the signal, it actually absorbs it and weakens it with every wall it has to pass through. It's a thing called signal attenuation. And you know what? A lot of the time, we're our own worst enemies without even realizing it. We see these mistakes constantly, hiding the router inside a TV cabinet to keep it out of sight, tucking it on the floor behind the sofa, or just shoving it in a far-off corner of the house. Every single one of those choices is like putting your Wi-Fi signal in a cage before it even gets a chance to get out. So at the end of the day, it's a pretty simple and, frustrating equation. You take all the physical barriers in your home, you add in a bad spot for your router, and you factor in the sheer distance it has to travel, and what you get is that dreaded dead zone upstairs. But don't worry, now that we've identified the bad guys in this story, we can finally talk about the solution. So let's look at the clear 2-part fix that's going to crack this case for good. Okay, solution A is by far the easiest and, honestly, often the most effective. Just move your router. I mean, just look at the difference on this slide. Going from that lonely corner to a central spot creates this huge, beautiful, even circle of coverage. For a lot of people, this one little change can solve the entire problem. So this all boils down to a really simple 3-point checklist. First, go central. Find the middle of your home if you can. Second, get it up high. Wi-Fi signals kind of radiate downwards, like a sprinkler, so getting it elevated is absolutely key. And third, try to give it the best possible line of sight, which really just means minimizing the number of walls that the signal has to punch through. But I hear you. What if your home's layout is just tricky? What if you've got really thick floors or a ton of walls, and even the best spot just isn't quite enough to reach that office upstairs? That is where solution B comes into play, the Wi-Fi repeater, sometimes called an extender. Think of it like a relay race for your internet signal. The repeater catches that weakening Wi-Fi wave, gives it a whole new burst of energy, and then blasts it out further into the house, covering those impossible-to-reach dead zones.
Okay, so we have all the pieces of the puzzle. Let's assemble our final case file and lay out the complete 3-step fix that's going to close this case once and for all.
So here it is, your complete case file. Step 1. Do a quick test downstairs to confirm your bandwidth isn't the problem. Step 2. Optimize your router's placement. Get it central, get it out in the open, and get it up high. And finally, Step 3. If that's still not enough to beat the interference, just boost the signal by adding a simple repeater. And that's it.
And just like that, you follow those steps and you can confidently declare your Wi-Fi mystery problem solved. The dead zone is officially history.
So now, you're not just a user. You're a troubleshooter. You cracked the case of the upstairs dead zone. Kinda makes you wonder, what other little tech mysteries around your home are just waiting for you to solve them?
You know that feeling when you're watching a video or playing a game and it just freezes? Buffering. It's the absolute worst, right? Well, imagine that frustration, but it's happening all day, every single day, for an entire office. Okay, let's dive into this case study and see exactly how they fixed it.
So let's meet the team at the Burgunge office. They were dealing with some major headaches. I mean, just try to imagine getting your work done when you're stuck on an ancient 3G network, using old hardware like these slow USB dongles and outdated routers. The impact was huge. Communication was always delayed, and trying to pull files from the cloud was just painfully slow. It was pretty obvious that an upgrade was needed, and fast.
Now, to really get why their solution was so brilliant, we need to wrap our heads around two key technical ideas. These two concepts, throughput and latency, are super important, and they pop up in exams all the time. They're basically the secret sauce that makes the internet feel either lightning fast or super slow.
First up, we've got throughput. The easiest way to think about this is to picture your internet connection as a water pipe. Throughput is just how wide that pipe is. A narrow pipe, like their old 3G network, can only let a little trickle of data through. But a really wide pipe, like a 5G network, lets a massive flood of data flow through all at once. So for things like cloud services that are moving huge files, you absolutely need a wide pipe.
Okay, the second key term here is latency. And if throughput is the width of the pipe, latency is all about the speed of the water inside. Think of it as the reaction time of your network. High latency, which is what you get with 3G, is like a slow-moving truck. It takes forever for a message to get where it's going and for you to get a response back. But low latency, the magic of 5G, is like a race car. The reaction is almost instant, which is totally crucial for things like smooth, lag-free video calls.
All right, so now that we know about throughput and latency, we can finally answer the big question. Why exactly was that 3G network holding the Burgunge office back so badly? What made it obsolete?
This chart here, this evolution of speed, it tells the whole story. 3G is basically tech from the past. It was designed for simple web browsing, and that's about it. The office was literally stuck on the bottom step of this ladder, while the rest of the world has moved up to 4G and now 5G, the kind of tech that makes things like the Internet of Things and instant cloud access possible.
So the problem is crystal clear. They need to jump from the past straight into the future. And the hero of this story, the technology that lets them make that leap is, you guessed it, 5G.
The magic of 5G really boils down to three main superpowers. First, it gives you that super wide pipe for data, so you get incredibly fast speeds for big files. Second, it's unbelievably responsive. Remember that race car we talked about, which makes video calls perfectly smooth. And third, it has this amazing ability to connect tons and tons of different devices all at once without ever slowing down.
And that third superpower, connecting lots of devices, is so important for something called the IoT, or the Internet of Things. IoT is all about connecting regular physical devices, like security cameras or office printers, to the internet. An old 3G network would just crash if you tried to do that. But 5G, it's built to handle it all, which makes an office totally future-proof.
Okay, so we've decided on 5G. Awesome. But here's the thing. You can't just flip a switch. When you upgrade the network, you also have to upgrade the actual physical hardware. It's time to do a major cleanout.
And this is exactly what has to go. These old 3G USB dongles and older gen routers, they're a physical bottleneck. They literally are not compatible with 5G signals. Keeping them would be like trying to catch a waterfall with a tiny teacup. It just won't work. They have to be replaced.
So, what's on the new shopping list? Well, first up is the brain of the whole operation, a 5G CPE router. This is the device that actually catches that powerful 5G signal from the air and turns it into super fast Wi-Fi.
Of course, to make that work, they need modern SIM cards that are 5G enabled. And finally, to make sure there are no Wi-Fi dead zones, a mesh Wi-Fi system can be set up to blast that amazing signal into every single corner of the office.
All right, the old hardware is in the bin, the new gear is all installed, so what was the result? Let's take a look at the payoff and see how this completely transformed the Burgunge office.
This before and after comparison just says it all, doesn't it? The days of buffering videos, agonizingly slow downloads, and random disconnects are completely gone. With 5G, they now have speeds that feel like fiber optic internet, but completely wirelessly. They can stream video in 4K and their files sync to the cloud in a blink. The difference is just night and day.
So this is the new workflow in action. That super fast, low latency signal travels from the 5G tower, gets caught by the new CPE router, and then gets distributed flawlessly to everyone in the office. What does that mean in real life? It means video calls are crystal clear, files saved to the cloud instantly, and the entire team can be online at the same time with zero lag.
Okay, we've gone through a lot, so let's boil it all down. This next slide is really important. Think of it as your exam recap. It pulls everything we've talked about into a simple summary that's easy to remember.
So here it is, the 3 pillars of this whole project. The issue: the office was stuck on obsolete 3G with slow, outdated devices. The tech: we used 5G, taking advantage of its low latency for a fast response and its high throughput for handling big data. And the fix: we ripped out the old hardware and installed a modern 5G CPE router. The result: a modern, efficient office. It's really as simple as that.
We've seen the incredible impact this had on just one office. But it leaves us with a really fascinating question to think about. Now that you understand the power of high throughput and low latency, where else could 5G be a total game changer? In hospitals? Maybe in our schools? What about in your own home? The possibilities are pretty much endless.
Okay, picture this. You're deep into an online game, or maybe you're just about to hit submit on that big assignment, and poof. The internet just dies. We've all been there, right? And it is so frustrating. But what if you could actually figure out why it's not working and fix it yourself? Well, in this explainer, we're going to become network detectives. We're going to learn step by step how to diagnose and solve these problems. It's a super useful skill for everyday life and, you guessed it, for acing those exams. So let's get into it. All right, first rule of network troubleshooting, before you even think about clicking anything on your computer, is to check the physical world. I'm talking about the actual physical wires that carry the internet to you. And these are the 2 main highways your data travels on. On the left, we've got the twisted pair cable. It uses copper wires to send electrical signals. This is probably what you have plugged into your computer at home. But on the right, that's the cool one, fiber optic. It has a super thin core made of glass, and it sends signals using flashes of light. It's literally data moving at the speed of light. How cool is that? So what's the difference between them? Pay attention, because this is a classic exam question. Copper is cheaper and a lot tougher, but it's also slower and can't send signals very far. Fiber, on the other hand, is ridiculously fast and can go for miles and miles, but it costs more, and that glass inside is pretty fragile. So you see, it's always a trade-off, cost and durability versus pure raw speed. Now, you can't just use the same plug for both, right? Different cables need different connectors. The copper cable uses that standard RJ45 connector you see on top. You know, that little plastic clip that makes that satisfying click when you plug it in? That's it. But fiber, down below, needs a special connector that's designed to protect that super delicate glass tip. And speaking of that delicate tip, here is a massive exam alert and a real-world warning. Never, ever, ever touch the end of a fiber optic connector. Seriously. The natural oils from your fingers can smudge the glass and completely block the light signal. It's such a simple little mistake, but it can bring the entire network to a grinding halt. Okay, so our cables are plugged in and they're secure. Now, what are they plugged into? Let's talk about the 2 most important little boxes that manage all of this network traffic. This picture shows the difference perfectly. Think of a switch as a local community hub. See how on the left it connects all the devices in one room or one office together? They can all talk to each other locally. The router, on the other hand, is the main door to the outside world. It connects your entire local network to the internet. So let's nail this down, because it's super important. A switch connects local devices together. A router connects that whole local network to other networks, like the internet. Just remember, switch is for local, router is for global. That distinction comes up all the time. You know, every single device on a network, your phone, your laptop, your game console, it needs an address. Just like every house on a street needs an address so the mailman can find it. Without an address, your computer is totally lost. And this house analogy is just perfect. Think of your computer as this house. Its unique street address, that's its IP address. It's a one-of-a-kind number that nobody else on the network has. And see that little gate leading out to the main road? That's your default gateway. It's the address of your router, the only way out to the internet. So, let's get the official definition down for your exams. An IP address is a unique ID for a device on a network. It is absolutely essential. If you don't have one, no data can find you, and you can't send any data out. Simple as that. And the default gateway? That's just the IP address of the router. It's the official exit door for your network. Your computer has to know the address of this door to send anything to the outside world. And now for the really fun part. We're going to open up that black command line screen, you know, the one all the hackers use in the movies, and we're going to learn how to use 4 super powerful tools that the pros use every single day to solve these network mysteries. Here they are, our 4 detective tools. First is ipconfig, our identity check. Then ping, our connectivity check. Tracert is our path check. And finally, nslookup is our name check. Let's break down what each one does. First up, ipconfig. This is always your first step. When you type this command, you'll see something that looks just like this. See that? It tells you your computer's IP address, and right below it, your default gateway. Now, if either of those is blank, well, you've just found your first major clue. Next up is ping. I love this submarine analogy. Ping is like your computer's sonar. It sends a tiny little packet of data out to another address, and then it waits for an echo, a reply. If you get a reply back, you know that other device is online. But if you see request timed out, well, that means nobody's home. The connection is dead in the water. So ping tells you if you can connect, but what if it fails? That's when you bring in the big gun, tracert. Tracert literally traces the entire route your data takes, stop by stop, from your laptop all the way to the final server. It's like a map of the journey, and if there's a problem somewhere along the way, Tracert will show you exactly where the connection broke down. And our final tool is nslookup. Here's the thing. Computers don't understand names like google.com. They only understand numbers, their IP addresses. So nslookup is like the internet's translator. It looks up a website name in a giant DNS phone book to find the correct number. If that phone book is broken or you can't reach it, you won't be able to find any websites. Okay, I know that was a lot of information, but don't worry, we can put it all together into one simple, logical cheat sheet that you can use every single time you have a problem. And here it is, your simple 4-step process. You just start at the top left and work your way across. Step 1, check the physical stuff. Are the cables plugged in? Step 2, check your identity with ipconfig. Do you have an address? Step 3, check your connectivity with ping and tracer. Can you reach anything? And finally, step 4, check DNS with nslookup. Can you translate names to numbers? If you follow these 4 steps in order, you can solve almost any network problem. All right, time for a lightning round recap for your revision. Ready? 1, physical first. Always check your cables. 2, a switch is local, a router is global. 3, ipconfig shows your IP address and your gateway, your exit. 4, ping is a pulse check to see if something is online. And 5, DNS is the internet's phone book that translates names to numbers. Got it? Good. And hey, if you need a really simple way to remember the troubleshooting order for an exam, just remember this silly sentence. Please don't call me. That's physical, DNS, connectivity, and my IP, which you check with ipconfig. It's a handy little trick to keep those steps straight in your head. So there you have it. You're not just a user anymore, you're a network detective. You have the tools and you have the knowledge. So the next time your internet cuts out, you're not going to be guessing anymore. You're going to be solving the case.